All right, we're going to talk about cross sections that are different. So like right here, this was a problem from back in 2007, and we give a graph. You got this graph, you got this line, and the region's bounded by those two. And we want to find the area of R. So that's what they're calling. R is both the first and second quadrants. Okay. Now the volume of the solid once rotated around the x-axis. That's something we just did. So you should feel pretty good about that. This was a calculator section, so you just like really be, you just set it up and shove it into the calculator. C is what we want to talk about now. So notice that the cross sections perpendicular to the x-axis are semicircles, and it's going to be really imperative for you to read this stuff when we go through it. So as with all of these, step one is to make a drawing, okay? Always. So just get used to that idea. Step one, make a drawing. All right, so we're going to draw out, we have y, let me write these down so then we'll switch over. Y equals 20 over 1 plus x squared, and y equals 2. Okay, so just trust me, I'm not going to draw this to scale because why would I? All right, so 20 over 1 plus x squared is going to do this thing. Okay, that's what it's going to look like. It's a belly curve, okay? And then we're going to have y equals 2. And they're calling this area right here. This is our region, okay? This is our region. Now, what we're going to do, we got to read this very carefully, and I'm going to grab different colors. So hopefully it can stand out. Yes, there we go. All right. Read very, very carefully. It tells us everything we need to know. So some people freak out about these ones, but it's all right there, actually. So for this solid, the cross section's perpendicular to the x-axis, and that's where we're going to like, okay? So there's a solid, okay? You got this solid, and we're going to slice it up, and we're going to slice it perpendicular to the x-axis. So all the slices are going to be perpendicular to the x-axis. And so imagine, we were talking about cheese today. So imagine, here, you see my friend, I got a spider just joined me. My wife would be freaking out right now. So can you see him? I'm not really quite getting in the spot. So there we go. Okay, so if I pass out, then, well, I guess we'll know what happened. But let's talk about cheese, okay? I heard some good ones. Personally, my favorite is pepper jack. Pepper jack's my favorite. All right. But what we're saying is, so imagine we got this block of cheese, and this is the bottom of the block of cheese. Okay, so this is the base. This is the base of our cheese, and so we're looking at the cheese. You can either think of like I'm looking at it straight down, or I'm looking at it from the bottom. Okay, this is the base of my cheese, and I'm going to slice the cheese. All right, and now the slices are going to be, it said perpendicular to x-axis. So perpendicular makes that right angle with the x-axis. So this is our little bit right here. And so now that little bit right there, what's that going to be? Dx right there. And so these are going to be perpendicular to the x-axis. And so the slices now are going to be really, really small. And so we're going to be adding up a bunch of dx. All right. Now, it says they are semicircles or semicircles. I've heard it both ways. So if we take this is a semicircle. And if this is a flat line, then obviously this part must be like so. Okay? So we got this. This is so I pull off the cheese and I lay it down, and it makes a semicircle like this. Okay? So you got the semicircle. Here's my slice of cheese. Okay. Now, this, of course, I like picking out foods because foods are real. And even if you slice cheese really thin, or even turkey, or heaven forbid ham, I don't know why anybody eats that stuff. But if we slice it out, and we can see like we get this, this little bit of depth to it. And that depth right there, that's our dx. But, okay, just like all of these things, really what it is, it has some depth, which means it is a three-dimensional figure. And so remember that the volume of any sort of thing, and this is basically a semicircular prism, okay, basically what it is. Now, it's not even a remotely real term, but it's what the idea is. So you're going to have this, the volume is the area of the base times the height. Well, this right here, our dx, that's our height, so that's dx. Now the volume, so the area of the base is the area of the semicircle. And how do you find the area of a semicircle? Well, it's going to be pi r squared over 2. Now r goes from the center of here to the edge. So it's pi r squared over 2. All right. So this one's extra complicated, and people had a really hard time with this one that year. Okay, especially because this was the first year that they started throwing these out there, and people were like, "Whoa, my goodness!" So anyway, so pi over 2, then we come out here because that's a nice constant. This r though, okay, this r is a function of x, and this is why I really try to stress not labeling things and using what the formula that the book uses, because this is a function of x, and this is r. R goes from the center of our semicircle to the edge, which means that R goes right here from the center, because that's the center, to the edge. This is R of x, okay? Not from here up there, not from here to here, and not even from here to there, okay? Those are all revolutions, and that's why the R was there. In this case, the radius is right here. And so the radius is, okay, well, how would I figure out what that is? Well, it's, you take this point and minus that point, and we divide it by 2. And that's how you'll find out how long that is. You take that distance divided by 2. This is the diameter. So the diameter of the semicircle, okay, the diameter of our semicircle is going to be our top minus the bottom, which in our case is 20 over 1 plus x squared minus 2. But we want the radius. Remember, the radius is half the diameter. So that's going to be 10 over 1 plus x squared minus 1. We just cut that in half. And so this now is the radius. And so we put that in here. So 10 over 1 plus x squared minus 1 squared. And so that's where we want to get to. Then, of course, right there, you would go through, integrate this. This was a calculator section, so you just shove that on into the calculator and get your answer. But that's how we want to set these up. And so we're going to take a look at some other shapes, because I've seen 3 other ways. We're going to hit all 3 of those ways that we could see this. Our book is very limited, so I'm going to have to probably make some up or hunt them down myself. But we'll find something, okay? All right, so that was 2007. 2008 did something, but 2009 did something better, because 2009 actually had 2 of them. All right, so again, we got y equals 2x, y equals x squared. Find the region. There you are. You can do that, no problem. Okay, so what they're saying now, again, step 1, make a drawing. All right, so 2x, and we have x squared. Okay. Now, hopefully it doesn't take too long for you to figure out that the intersection point is 2, 4. That's going to be really, really important. Okay. So now, we're going to take a look. Region R is the base of a solid. Okay, again, if we want to think in terms of cheese, okay, so let's say we got a block of provolone, okay? So we got provolone here. And what's going on is that this right here, this is the region here. This is R. This is the base of the solid, okay? And it says each x, at each x, the cross-section perpendicular to the x-axis, right there, okay? Cross-section perpendicular to the x-axis. At that point, when you read that, you come back to your drawing, and we draw a cross-section perpendicular to the x-axis, okay? So this is right there. That's cross-section perpendicular to the x-axis. Is it all? You suppose it's always going to be perpendicular to the x-axis? No. Perpendicular x-axis. Okay. In fact, actually, on part C on this one, it's going to not be. It's going to be perpendicular to the y-axis, but it's cross-section perpendicular to the axis. Okay, so that means that that's our little bit. Okay, so now we're going to end up. Okay, and so we have this. This is our depth right here. So that's our dx going on. Because remember, this is right here. Dx, that little bit of distance right there. So dx, and then it's going to have some weird shape. Because if we take a look here, it says the cross-section perpendicular to the x-axis has an area of this. Okay, now when we look at this, this is really interesting because whatever shape this is, okay, so it is some kind of weird shape. It doesn't matter what it is. This section has an area of a sub a of x, meaning that whatever is going on right there. Let's see how my three-dimensional skills are going. Okay, so we got this flag shape or whatever it is. Okay, almost kind of looks like. Yeah, I don't even know. Okay, but okay, so we got this shape. We don't even need to know what kind of shape it is, because remember, this is some weirdly shaped prism. Just think that. It's just a weirdly shaped prism. That means our volume is the area of the base times the height. Always. No matter what. So the volume is going to be, the area of the base is a of x. The height is dx. And if we're going to add up a whole bunch of those, then all we're going to do is we're going to do the integral of a of x. A of x was sine of pi over 2x dx. Okay, because this is what, right there, a of x is sine of pi over 2x, like so. All right, and then we're going to go from 0 to 2. From 0 to 2. Oh, oops. Back here. Just realized we didn't figure out where these points were. Here. All right, so what we do is we go, okay, well then we say 2 equals 20 over 1 plus x squared. So 1 plus x squared equals 10, x squared equals 9, x equals plus or minus 3. So it's negative 3 to positive 3. That's what that was. So, my bad. All right. Okay, and again, right there, that's actually a pretty simple one, but you know, this would be a calculator one, so don't even worry about it. All right, now let's take a look at another one. Another solid has the same base. Okay, so we got another block of cheese. All right, so let's say it's mozzarella. Okay, love that stuff. Okay, so cross section is perpendicular to the y-axis. Cross sections perpendicular to the y-axis. All right, so let's go with pink. All right. So this right here, okay, that's a cross section perpendicular to the y-axis. Is what's going on there. Okay. So now that little space right there is dy. is what's going on. And so we got these things, and so now we're going to have something going on like this, and then the height is going to be dy. Is what the height is going to be. It's going to be h. Now let's see what kind of shape it was. Or squares. Okay, we're going to be squares. So they're going to be squares. And so we take this slice of cheese out and we put it right there. So this is our cheese right there. And so this is a square, which means that all the sides are the same. So whatever this distance is right here, this we'll call L right there, that length, this is L, and so is this. So we got to figure out what this L is. Well, if this is dy, right, you got dy going on, well then we need to have this L in terms of y. We need L of y. All right, well, these are both in terms of x, so we got to rewrite those. Y equals 2x means x equals y over 2, and y equals x squared means x equals radical y. All right, cool. And so the length between 2 points, if this were at 3 and this were at 1, we do 3 minus 1, we get 2. If this were at 2.5 and this were at 1.5, we do 2.5 minus 1.5, we get 1. We do the bigger minus the smaller. And so it's going to be L of y, the outside one, okay, because this is the bigger value. It's going to be radical y minus y over 2. There we go. So that's L of y. Now, again, just a prism, and it is actually a square prism, rectangular prism. Base times height. Well, they're both L. So L squared is going to be this squared, is what that's going to be. So that means then we'd have the integral. We'd have radical y minus y over 2 squared dy. And since these are y, these should both be y. We go from 0 to 4 in the y direction. 3 to 4. And why is there no pi here? Everything else has had pi so far. Why is there no pi? It's a square. It's not a circle. It's got nothing to do with trig functions and unit circle and things like that. It's just a square. So nothing to do with circles. So a lot of these ones won't end up having pi involved. And so if you're like me and Arnold and forget to write pi down a lot, well then, hey, it works out well on these ones. So, yeah. And then, of course, you can FOIL that or and go from there. But this one, actually, some of these things, what they'll do is write, but do not evaluate an integral expression for the volume of the solid. All right. One more. Okay. So, find the area of R. We revolve it around the line y equals 7. You get this sideways, like a sideways volcano. Scoozy. Okay. Now, region R is the base of a solid for each y from 0 to 6. That's from 0 to 6. They actually gave us that intersection point. That was nice of them. From 0 to 6, the cross-section of the solid taken perpendicular to the y-axis is a rectangle whose height is 3 times the length of its base. All right. So it says the R is the base of the solid. This is the base. This is the bottom, okay? So we have a rectangle that's going to be taken out, and this is going to be a slice. And so all the slices this way are going to be rectangles, okay? So maybe some Colby Jack, if you will. Definitely no American cheese product. Stuff's nasty. There's only 2 times where I actually even will eat that stuff. Number 1, grilled cheese. And number 2, the Brandt family specialty, peanut butter and cheese sandwiches. Okay. So if you think that sounds dry, you're right. It is. Oh my goodness. So yeah. Anyway, our perpendicular. So we got these sections. Okay, and they're perpendicular to the y-axis, so they go like this. And so again, a little bit of change right there is dy. Okay, and so now what happens now? It says, remember, this is the base. So we can call this little b, if we will. So that's our base right there. Base, base, base. So there's the base. Okay, and then we have the height. All right, so we got this. We got this slice. Now, we are told that a height is 3 times the length of the base. And again, the base is in region R, so the base is in R. Okay, so lots of different things to show that this one is the base. Okay, that these two, this side and that side are the same. Those are the ones. But this is 3 times the base, so that's 3b. All right. So if we want to find the volume of this rectangular prism, remember, base times height times depth, because that's what this is. This is our depth right there. So our base, well, that's b. Our height, well, that's 3b. Our depth, well, that's dy. That's what dy is. It's our depth. All right, so we end up with 3b squared dy. But we want this, we want b in terms of y. Well, we are told that this right there is 2 radical x. So y equals 2 radical x. This is a function in terms of x now. We got to get in terms of y. So we'd end up with y over 2 equals radical x. We square that. So we end up with y squared over 4, or 1/4 y, or however you want to call it. Okay, and that's going to be, so b is going to be 1/4 y squared. So then we come back here, and so we'd have the integral. So we're going to have 3. We have b squared, so that's 1/4 y squared dy, going from, and then y, so in the y direction, from the bottom to the top. So it goes from 0 to 6. 0 to 6, 0 to 6, 0 to 6, yeah, 0 to 6. From y equals 0 to y equals 6. Like so. And then if you wanted to simplify this down and pull some things out, remember, if we square that, we don't just pull out 3/4, we could pull out 3/16, because we're going to have to square that 1/4. So we end up with 3 over 16 times the integral from 0 to 6 of y to the 4th dy. And then y to the 5th over 5, and so you'd end up with 3/80 times 6 to the 5th. Yeah, that's fun. So yeah, you're going to want a calculator for that one. All right, so these are just some variations. I'm going to hunt down some more for you, or make them up, so that way you can get some practice with these. But yeah, totally doable. Just think in terms of cheese.